Hello students, today I am here to teach you chapter 8 in your textbook, that's about triangles 1. So here in this lesson we'll discuss about what are interior and exterior angles of a triangle. So we'll take a triangle. We'll label it A, B, C. What are these angles? This one, and this one we call interior angles. So how many interior angles in a triangle? There are 3 interior angles. So we'll label this angle. So how can we label A angle? So we can write BAC, or we can write the other way around, CAB, or simply I can write A angle. What about this angle? I can write ABC, or how can I write? I can write the other way, CBA, or simply B angle. Now label the third angle, ACB, or I can write BCA. Simply C angle. So these angles are interior angles of a triangle. Now we'll see what are exterior angles. So here, how can we get exterior angles? When you take any line and when you extend that line to another point. For example, this one, BC line extend to D point. So what you call this one? BC produced. We call this is BC produced up to D. So when we are extending a line, we get an exterior angle. So when you extend this line, this angle we call the exterior angle of a triangle. So here I can write ACD is the exterior angle. Now in this triangle, I produced QP up to S. QP up to S. So here QP produced up to S. Then this angle we call the exterior angle. So SPR. Or I can write other way around as well, RPS. That's the exterior angle. Here in this one I can write instead of ACD, DCA as well. Same angle. What about this triangle? Which one is the produced up to this one? XY line produced up to M. XY produced up to M. Then what's the exterior angle? We get MZY, or I can write YZM. That's the exterior angle. So now you know what are interior angles and exterior angles. Now we'll try to find out a relationship between those interior angles and exterior angles. Now take this example. So you have given ABC triangle and BC produced up to D. So here we'll see, this is the exterior angle we are getting. We'll try to find out a relationship between the interior angles and this one. What are interior angles? BAC, that's given 60 degrees. ABC, that's given 40 degrees. And this is also interior angle. ACB is an interior angle, but ACD is an exterior angle. Now here, when you take this angle, it's interior. But here when you take these two, we can say opposite interior angles to the exterior angle. What about this example? These are the opposite interior angles and this one is the exterior angle. In this example, these are the opposite interior angles and this one is the exterior. In this one also, opposite interior angles, this one is the exterior angle. Now, we'll try to find out a relationship between those two angles. First, I'll write down this one. These two are, we can call it opposite interior angles. Now, I'm constructing a line so that this line is parallel to AB. I'm constructing a line parallel to AB line. Then what can I say about this angle? This and this angle. What is this angle? Can you see Z angle? Alternate angles. When you draw two parallel lines, you get something like this. So what are these angles? Alternate angles. So I can write this. If this is 60, this is also 60. So what's that angle? If I take this one as E, ACE angle is 60. What about this angle? DCE or ECD angle. Here, can you see F letter angle? What you call that? F. If these two lines are parallel, these angles are equal. What you call that? Corresponding angles. So corresponding angles are equal when the two lines are parallel. So I can write this is 40 because all corresponding angles. So here ECD angle is equal to 40 degrees because of corresponding angles. Now, what can you say about this exterior angle? This is 60, this is 40. When you add these two together, you get the exterior angle. So here we found a relationship. If we know the two opposite interior angles, we can find out the exterior angle. So here we can see that ACD is equal to 60 plus 40. Now we'll take this one and try to find out a relationship. There I can construct a line parallel to PR. Then what happens? This PRQ angle is same as this angle. If I say this is S and T, so TQS angle is 40 because that's corresponding angles. Then what about this angle? TQP angle. That's equal to 90 degrees. This angle and this angle, alternate angles. So here I can write TQP angle is 90 degrees. What's the reason? Alternate angle. When I add these two together, I see this whole angle is the exterior angle. PQS angle PQS or SQP. You can write both ways. That angle is equal to sum of these two. Now we'll take this example. Then straight away, can you find out this angle? Now earlier we constructed a parallel line, but without drawing a parallel line, what's the relationship? We see the sum of these two angles is equal to the exterior angle. So here, without drawing the line, I can write this is equal to 70 plus 60. What about this triangle? This is the exterior angle and these are the interior opposite angles. So I can write this is equal to 85 plus 35. So that's the relationship between the exterior angle and the interior angles. So now we'll see theorem number 1. So theorem number 1 says the exterior angle formed when a side of a triangle is produced is equal to the sum of the two interior angles. So here what it says, when you get a triangle ABC, when one line is produced, you get the exterior angle. So this is the exterior angle. So that exterior angle is equal to the sum of the two opposite interior angles. So here these are the two opposite interior angles. So here sum of these two is equal to the exterior angle. So we can write down, if this is DABC angle plus BAC angle is equal to ACD angle. So what it says in theorem number 1, when you get a triangle and one line is produced, you get an exterior angle. So that exterior angle is equal to the sum of opposite interior angles. So remember this and we'll try to apply this theorem in applications. Now before that we'll try to prove. So for that I am taking a triangle ABC and then I am taking BC produced up to D. So here to be proved, I need to prove this plus this is equal to this angle. So I'll write down, I need to prove CAB plus ABC angle is equal to ACD angle. So that's what we need to prove. So for that we need to do a construction. So I'll draw a construction. I'll write here construction. I'm drawing a parallel line along C to AB. Parallel line CD to AB line. So this line is parallel to this one. So I'll label this as CE line. So I can say AB line parallel to CE line. Now we'll try to prove this. So we need to prove these two angles is equal to the exterior angle. So here, when you take this angle, so when you take that one, BAC angle is same as what? This angle. Why? If these two lines are parallel, you get alternate angles, so alternate angles are equal. So I can write BAC is equal to ACE. Alternate angles. Then this one, ABC angle is equal to this angle. So this angle is ECD. What's the reason? Corresponding angles. Then I want to add these two. This is the first one. This is the second equation. I'm adding these two. Then I'm getting these angles. BAC angle plus ABC angle is equal to. Now look at this one. ACE plus ECD. So you get this full angle. So that's ACD angle. So that's the exterior angle. So here sum of these two angles is equal to the exterior angle. So that's what we need to prove. Now we'll apply that theorem in several applications. Now when you look at this triangle, we straight away see these two are opposite interior angles and this one is the exterior angle. So according to theorem number 1, we can write 80 plus x is equal to 120. I can write theorem number 1, exterior angle is equal to sum of opposite interior angles. So how can we find out the unknown value? We can straight away find out x angle is, take 80 to the other side, 120 minus 80, you get 40 degrees. Now you can find out the other unknown values using the same theorem. Now when you look at this one, we can say 90 plus x is equal to 140. So you can apply the same theorem. Then how can I find x? X is equal to 140 minus 90. So what's the answer? 50 degrees. Now look at this one. These two are the opposite interior angles and this is the exterior angle. So according to theorem number 1, I can write 2x plus x is equal to 114. So now we get like terms. 2x and 1x becomes 3x. So 3x equals 114. So what is x? You divide this by 3. So you get 3 times 3, 9. For 24, that's 8. So 38 degrees for one x angle. Now we'll look at example 1 in your textbook. So it says find the magnitude of ACB. ACB. So this angle based on the information in the figure. So this is the exterior angle and these two are the opposite interior angles. So according to theorem number 1, what can you say? ACB plus 60 degrees is equal to the exterior angle. Then you can take 60 to the other side and find out the ACB angle. So ACB angle is 110 minus 60. You get 50 degrees. So here you need to write down the reason why this is equal. According to theorem number 1, exterior angle is equal to sum of opposite interior angles. So this angle ACB becomes 50 degrees. Now we'll look at example number 2. Based on the information in the figure, find the magnitudes of AEB. Identify that angle AEB, that's X angle, and BCE. BCE, that means Y. So basically they are asking what's the value of X and Y. Now try to find out what can we say about this angle, X angle. Now look at AED triangle. When you look at AED triangle, we can say straight away X is equal to 25 plus 70 because sum of opposite interior angles add up to exterior angle. Then what's the X value? You get 95 degrees. Now look at the small triangle BCE triangle. When you take BCE triangle, we can see these two angles are the opposite interior angles and X angle is the exterior angle. So what's the relationship between that? 40 plus Y becomes X value. That's the exterior angle. But we found out X is 95. So you can find out the Y value. So what is Y value? 95 minus 40, you get 55 degrees. Now we'll look at exercise 8.1 in your textbook. The question number 1 says find the magnitudes of the angles represented by letters in each of the figures. So here X, here N and X here. So we'll try to find out those angles. In the first one, straight away we see what's the X value? The sum of opposite interior angles is equal to the exterior angles. So here we can add these two together to find out X. You get 80 degrees for the first one. What about this one? Look at carefully. So here these two lines are parallel. If this is 55, we can say this is also 55. What's the reason? Alternate angles. Then what can you say about this one? This angle and this angle add up to 100. And after you get this angle, you can find out N. So here straight away we can write down 100 is equal to 55 plus, I'll put this one as X, So what's x value? X is 100 minus 55. So what you get? 45 degrees. After you get 45, how can we find out n? What can you say about this angle? That's a straight angle. That's equal to 180. So x plus n. So 45 plus n is 180. So what's the n value? 180 minus 45. You get 135 degrees. Now look at the third one. Look at carefully and see. When you take LPM triangle, these two are the opposite interior angles to the exterior angle. So we can write 135 is equal to 45 plus x. So how can we find out x? X is equal to 135 minus 45. You get 90 degrees for the x value. Now we'll take this question. So in this triangle, this full thing is given A. So here these two angles are the opposite interior angles to B. Now when you take this one, here this is 40. So straight away I can write what's the B angle? B angle is 40 plus 70. So that's equal to 110. After you get this one as 110, I can write A, the full angle. So the full angle A plus 50 degrees should be equal to the B angle. B angle we found, that's 110. So A is equal to 110 minus 50. You get 60 degrees for A angle. Now we'll look at this one. When you look at this triangle, we see these two angles are the opposite interior angles to this one. So straight away I can write D plus 2D is equal to 120. So 2D plus 1D becomes 3D. Then D, 120 divided by 3, you get 40 degrees. Now after you get this one, we need to find out C angle. When you look at this triangle, I can see C plus C should be equal to 120. Sum of opposite interior angles add up to the exterior angle. So 2C equals 120. What's the C value? 120 divided by 2, you get 60 degrees. Now look at this one. This one I can straight away find out n. What's n angle? 70. What's the reason? Opposite angles are equal. Then I can say this also 50. Opposite angles are equal. Now these two becomes m. The sum of 50 plus n angle. N is 70. That should be equal to m. So what's the m value? 120 degrees. Question number 2. Express D in terms of ABC based on the information in each figure. Look at this diagram. When you take this triangle, we can write this angle as what? These two are the opposite interior angles. So this is the exterior angles. I can write this one as A plus B. Then think about small triangle. This is A plus B. This is C. This is the exterior angle. So how can we write down D? D is equal to sum of opposite interior angles. So we can write A plus B plus C. So D is equal to A plus B plus C. Now look at this diagram. What can you see? When you take this big triangle, this is B, this is C. What can you write about this angle? This is the exterior angle to this triangle. I can write this angle is B plus C. These are the two opposite interior angles. Then think about this small triangle. This is B plus C. This is A. This is the exterior angle. So what can you write about D? Sum of opposite interior angles add up to the exterior angle. So I can write A plus B plus C is equal to D. Now we'll look at example number 1 in your textbook. It says the point S is located on the side QR of the triangle PQR such that PQS, this angle is equal to SPR. So here this small angle is equal to that one. Prove that QPR, this full angle is equal to PSR angle. This angle is equal to this angle. So here we need to find out PSR angle is equal to QPR. That's what we need to show. But we know PQR or this angle, PQS or PQR, same angle, PQR or PQS is equal to SPR. It's given there, SPR. That's given. So here, according to this angle, I know these two add up to this angle. So here, what can I write instead of PSR? PSR is equal to sum of interior opposite angles. I can write PQR plus QPS. Now, instead of PQR angle, I can write SPR. Now, what is this? SPR. This angle plus QPS angle. What you get? The full QPR angle. So, this becomes QPR angle. So, that's equal to PSR. So, that's what you need to prove. Now, we'll look at example number 2. It says, based on the information in the figure, prove that BAC angle, BAC, this angle plus ABC, this angle is equal to DEC. DEC is this angle. So, sum of those two angles add up to this one. So, here I can write according to this one CBA. CBA angle is same as this one. Why? What's the reason? The two lines are parallel. So you get F letter angle. That's corresponding angles. Now we can see, look at this triangle, ADE triangle. I can write ADE angle plus BAC angle. This angle is equal to CED angle or DEC angle, because sum of opposite interior angles add up to the exterior angle. Then what can I say about this angle? AD is same as CBA. That's corresponding angles. Plus BAC is equal to DEC. Now we want ABC. ABC is same as this, so I can rearrange this to ABC plus BAC angle is this one is equal to DEC. So that's what we need to prove. Now we'll take exercise 8.2 in your textbook. It says if BDF, this angle is equal to EAF, this angle, fill in the blanks in the following statements to prove that FBC is equal to FEC, this angle. Now we'll try to fill these blanks. So here FBC, we can write, this is the exterior angle to which one? This small angle. So I can write this is equal to FBC is this angle is equal to FDB or FDC angle plus this small angle. So this small angle is BFD. What's the reason? Sum of opposite interior angles add up to exterior angle. Then it says but BFD angle is equal to this angle, vertically opposite angles. So I can write this is equal to AFE. Then BDF, this angle is equal to, this angle is equal to this angle, it's given, BAC, it's given, or data, we can write this is data, given data. Now what can we say about FBC? FBC, this angle is equal to these two angles. No? So instead of this angle, I can write this and this. So I can write this is equal to AFE angle plus BAC angle, these two. But we know FEC angle is sum of these two. So sum of these two means EFA angle and FAC angle. That's the exterior angle. So what can you say about these two? Now look at these two carefully. EFA or AFE plus FAC. FAC is same as EDC angle. We found that is equal already given. So what can we say? Same thing here. So we can write FBC angle is equal to FEC angle. Now we look at the second question. As indicated in the figure, AB and CD are parallel. Already marked. Prove that AEC, this angle is equal to BAD angle plus ECD angle. These two is equal to this angle. So we'll first look at this one, and what can we write about this angle and this angle? We can say according to this one, BAD angle is equal to CDE angle. What's the reason? If the two lines are parallel, those are alternate angles. And when you add this angle to both of these, what happens? I'm adding this angle, DCE angle. What happens? CDE plus DCE. What happens when I add this angle to both of these? What happens? BAD plus this one, BAD plus DCE is equal to, can you see? I want this side. DCE plus BAD becomes, what is this one? CDE plus DCE. We'll try to find out this angle, CDE. CDE, this angle, plus DCE. DCE angle, this one. What can I write? That those two are opposite interior angles to this one. So I can write, instead of these two, I can write CEA angle. Why? That's the exterior angle. So I get what is required. BAD plus ECD, same as DCE, is equal to CEA or AEC. We'll look at third question. It says, as indicated in the figure, PQR and PRS are right angles. So here it's given. If QRT is a straight line, prove that QPR is equal to SRT. We need to show these two equal to that. Okay, when you look at the big triangle, PQR triangle, what can we say? I can write QPR angle plus 90 degrees, these two, is equal to PRT angle. That's the exterior angle. Then PRT I can write as PRS, that is 90 degrees plus SRT angle. I can split this angle to this plus this. Now what can we see? When you add 90 to both sides, I can see this one get cancelled out. Then what I can see, QPR angle is same as SRT angle. We'll look at the fourth question. The lines AB and CD intersect at each other at the point E indicated in the figure. Based on the information in the figure, show that A equals 2x. Okay, so we'll try to find out. According to these two angles, I can write these two angles add up to this one. So this is A, this becomes 2A. And then I can write these two add up to 2A. So according to this one, I can write 3x plus x is 2A. That's the exterior angle. Then 3x plus x becomes 4x. 4x equals 2A. Then when you divide both sides by 2, what you get? 4 divided by 2 is 2x. 2 get cancelled out. We get A equals 2x. Now we'll look at question number 5. It says in the given figure, PRQ, this is already marked as PSR. So this PQ, RPS angle already marked. Based on the information in the figure, show that PQT is this angle is equal to 4 times PSR. 4 times this angle, but they have given PSR take as x. So I'll take this one as x. And I can see this angle is equal to this angle. So I can take this is also x. Then how can I write this angle? I can write PRQ angle is what? PRQ or PRT or PRQ angle is equal to 2x, x plus x. You get 2x angle. And I can write this angle plus this angle. Can you see this is also equal? So according to this given information, PRT or here this one PRQ. This angle is same as QPR. So this angle, so this is 2x because already given. So I can write what is this angle? TQP or PQT angle is equal to 2x plus 2x. That's equal to 4x. But what is x? We took x as PSR. So I can write what is PQT angle? 4 times PSR angle. We'll look at question number 6. It says PQR is a triangle. So the diagram is not given, so you have to draw it. PQR is a triangle. RS is perpendicular to PQ. So here, somewhere here. So this is RS. Then it says QT also perpendicular to PR. So that's given. Then the two lines intersect at U. Prove that SQU, what is that angle? SQU is this angle is equal to TRU angle. TRU angle is this one. So how can we prove that? So look at carefully according to this one. Now we'll take this angle as x. So I can write this angle is equal to this angle. Those two are vertically opposite angles. So I can write SUQ angle is equal to TUR angle. Vertically opposite angle. And here when you look at this angle and this angle is equal to 90 degrees. So I can take SQU triangle and write down SQU plus SUQ is equal to 90 degrees. So 90 degrees, because it's given PSR angle is 90 degrees. And also I can write about these two. I can write, when you take UTR triangle, I can write, this is 90 means this is also 90. So that's the exterior angle. So I can write TUR plus TRU angle is also 90 degrees. Now these two are 90 degrees, so I can equate these two. So what can I write? I can write SQU plus SUQ angle is same as TUR plus TRU. When you look at 1 and 2. Now what can we say? We know these two angles are equal. This angle and which one? SUQ, these two. So you can cross it out. So same angle, so you can cross it out. So what you get? We get SQU angle is same as TRU. So that's what we need to show. Now we'll look at question number 7. In question number 7, it says the side BC of the triangle ABC has been produced to E. So we'll try to draw a diagram. So there's a ABC triangle. And it says the straight line BC produced to E. So here BC produced to E. And it says the straight line AD, there's a straight line AD has been drawn such that it meets the side CE. So here somewhere there D, there's a straight line AD, it meets CE at the point D and such that BAC angle, this angle is same as CAD, this angle. These two are equal. And also ABC angle, this one, we'll take this one as this angle, BAC angle. So this is equal to this angle given. Now what can we say? We know this is X, this is also X, and also it says these two angles are equal. So we can put this is also X. Prove that ACD, this angle is double of 2ABC and AD is triple of ABC. Now we can take this one as X. What can we say about this triangle? When you take ABC triangle, I can write ACD D angle is x plus x because that's the exterior angle. So what is x plus x? That becomes 2x. So what is x there? Instead of x, I can write ABC because so I can say this is 2 times ABC angle. So that's the first part. Now look at the second part. We want ADE, this angle. So what can you say about this angle? When you look at the big triangle ABD, this is second part, ABD triangle, what can I say? ADE is equal to, this angle is this plus this. So I can write x plus x plus x. This whole thing is x plus x, that's 2x, and this is x. So what you get here? I get 3x. Again, what is x? X is ABC angle. So I can write instead of x, ABC. So what I get? ADE angle is 3 times ABC. So that's the second part. Now we'll look at the second theorem in your textbook. That's about interior angles of a triangle. So what's the theorem number 2 says? The sum of interior angles of a triangle is 180. So we'll draw a triangle ABC. So here what are interior angles? BAC, ACB and CBA. So here we need to prove that these three angles add up to 180. So here what it says, according to the theorem number 2, the sum of angles, interior angles add up to 180. I can write BAC plus, BAC is this angle, ACB is this angle and CBA is the other angle, that's equal to 180. Or I can use simply, instead of this angle, I can write A angle plus C angle plus B angle is equal to 180. So we'll try to prove this. So here what I can do, I can extend BC line to D. So BC produced up to D. And then I want to draw a parallel line to AB. We'll call it CE. So what's the construction I have to do? I have to draw BC produced up to D, as well as I want to draw a parallel line to AB. So AB line parallel to CE. So those two lines I need to draw. That's the construction. Now what can I see? I see that this angle is same as this angle. So I can write ABC angle is same as ECD angle. What's the reason? What's the reason? These are corresponding angles. And also I can write this angle, that's BAC angle is same as this angle. That's ACE angle. What's the reason? alternate angles. Now I want to add this angle to both sides. So I am adding ACB. ACB to both sides and add all three together. 1, 2, 3. When I add all these three together, I get ABC plus BAC plus ACB is the sum of interior angles. So here I get A angle plus B angle plus C angle there. What is this one? ECD. Here ECD. ECD. This angle and this angle. So what's the sum of all three angles here? I get 180 because that's a straight angle. So here sum of all these angles add up to 180. So that's how we can prove the second theorem. So what is the second theorem? The sum of angles in a triangle adds up to 180. Now we'll look at example 1 in your textbook. It says find the magnitude of ACB, this angle, based on the information in the figure. So here these three are interior angles. So what we can write? According to second theorem, I can write 60 plus 40 plus ACB is 180. So what is ACB? 60 plus 40, 100. So I can take 100 to other side and subtract. I get 80 degrees for ACB. Example number 2. It says find the value of x based on the information in the figure. So here all these three angles are interior angles. So according to theorem number 2, it says 2x plus x plus 30 is equal to 180. Sum of angles in a triangle is 180. So 2x and x becomes 3x plus 30 equals 180. So take 30 to the other side. You get 3x equals 180 minus 30. So what you get here? 180 minus 30 becomes 150. So what you get for x? I can divide this by 3. So x is equal to 3 times 5. So 50 degrees. Now we'll look at example number 3. The straight line AB and CD intersect at E. ADE is given 35, DAE is 70 and ECB 55 degrees. Find the magnitude of CBE. Which one is CBE? This angle. First draw a figure with a given information already there. So here what can we see? When you look at these three angles here, first we can find out this angle. So what is AED angle? That is equal to 180 minus these two, because sum of angles of all three, this and this and this, becomes 180. If we want this one, we can subtract these two from 180. I can straight away write down 180 minus 70 plus 35. So what's that? 180 minus the sum of these two becomes 105. 180 minus 105 becomes 75. So 75 degrees for AED. So that means this is also 75. Then what can we say about this triangle? Again, I can write CBE. CBE angle is what? I can write 180 minus sum of the other two angles. So 75 plus 55. So 180 minus what you get here, 130. When you subtract these two, you are getting 50-degree angle for CBE. So we applied sum of angles of a triangle adds up to 180. Look at example number 4. It says determine whether there can be a triangle with interior angles 55, 60, 75. So here in a triangle, these three angles given 75, 60 degrees and 55. So we'll add and see whether it's equal to 180. If it's equal to 180, that means there's a triangle with these angles. If it's not, we can't make a triangle with these three angles. So we'll add up these three angles, 75 plus 60 plus 55. What you get? 5, 5, 10, 1 remaining, 8, 6, 14, 14 plus 5, 19. So 190 degrees. So this is not equal to 180. So that means we can't draw. There is no triangle. With these angles. We can't draw a triangle like this. We'll take exercise 8.3 in your textbook. So here you are asked to find out the angles here, ACB here, XYZ and QPR for the other one. So we'll try to find out. ACB is this angle. So what can we say? We can say this is sum of these three is equal to 180. So what is the angle? This angle becomes 180 minus sum of these two. What's sum of these two? You get 5, 7 plus 5, 12, 125. So when you subtract, you get 5, 5, 10, 1 remaining, 3 and 5. So 55 degrees for ACB. What about this one? XYZ. XYZ means you want this angle. But we know if this is 55, this is also 55. Vertically opposite angles. Then we can write XYZ angle is what? 180 minus sum of these two angles. So 40 plus 55. 180 minus, add these two together, 5 and 9, 95. When you subtract these two, you get 5, 5, 10, 1 remaining. This is 10 and 18. So here 85 degrees for that one. Now look at the third one, QPR. QPR. That means we want this angle. So according to this diagram, these two lines are parallel. So if this is 65, this is 65. That's alternate angles. Now we can write QPR angle is 180 minus these two, 65 and 70. So when you subtract these two, you get, and this 5, 7 plus 6, 13. So 180 minus 135. So you get 45 degrees for QPR angle. Now look at question number 2. Using the given information, find the magnitude of each of the angles denoted by a letter. So here first one X, the other one P, and the third one A. What can we write? These are interior angles. So sum of interior angles add up to 180. So x plus 40 plus 80, you get 120. Then what is x? 180 minus 120, you get 60 degrees. Again this one, sum of angles. P plus 110 is equal to 180. So P plus P becomes 2P. Then 2P is equal to 180 minus 110. When you subtract these two, you get 70. So 2P equals 70. So what's P? You need to divide both sides by 2. So 70 divided by 2, you get 35 degrees. This one, again, sum of angles in a triangle is equal to 180. Now, add like terms A and 2A. You get 4A minus 30 and plus 10, you get minus 20 is equal to 180. So 4A equals what? Minus 20, take it to the other side. That becomes plus 20. 180 plus 20 becomes 200. 4A equals 200. How can we find out A? Divide both sides by 4. Then A equals 4 times 5. So A value is 50 degrees. Now we look at this one. These two lines are parallel. If this is 45, straight away we can write this one as 45. Why? What's the reason? Alternate angles. Then what can you say about these three angles? This is sum of interior angles. So I can write P plus 45 plus 65 is equal to 180. So when I add these two, what you get? 5 plus 5, 10, 1 remaining, 7 plus 4, 11. So 110 is 180. P equals 180 minus 110. You get 70 degrees for P. Look at this one. Here, I can find out M. So this is big angle, this one, and this is 50. When you look at the big triangle, I can write 50 plus 55 plus 30 plus M equals 180. Add these three, you get 5, 5, 10, 13. 135 plus M equals 180. What is M? 180 minus 135. So when you subtract, what you get? 5, 5, 10, 1 remaining, 4. So 45 degrees for M. Now I can find, this is 45. I can use the small triangle and find out N. So what can I write? I can write N plus 30 plus 45 equals 180. 30 plus 45 is 75. And what's N? 180 minus 75. I get 5, 5, 10, 1 remaining. So 8. So 105 degrees for N. Now look at the next one. Next diagram, I can see these two lines are parallel. And also, when you take these three angles add up to 180. So straight away I can write 105 plus 35 plus D is equal to 180. So when you add these two, you get 5, 5, 10, 1 remaining 140 plus D equals 180. So what's D? You subtract 140 from that. So you get 40 degrees. So we found out this is 40. Then if this is 40, I can write this is also 40. Alternate angles. Then I can look at this small triangle and write down 40 plus C plus 70 is equal to 180. 40 plus 70 is 110. So what is C? 180 minus 110, you get 70 degrees. Now we'll look at question number 3. For each of the triplets of angles given below, determine whether they can be the interior angles of a triangle. So what's the rule? When you add all three angles, add up to 180. So we have to check each one whether it's 180 or not. So the first one, 50 plus 40, 90. 90 plus 90, you get 180. That means this is a triangle. Second one, 70 plus 30, 100. 100 plus 75, 175. So you can't make a triangle with these angles. Part 3, 55 plus 72 plus 58. What's the sum? 8 plus 2, 10. 10 plus 5, 15. 1 remaining. 6. 6 plus 5, 11. 11 plus 7, 18. So 185. So that means you can't make a triangle with that. Fourth one, 60 plus 60 plus 60, you get 180. So that's an equilateral triangle. So you can make a triangle. Fifth one, 100 plus 20, 120. 120 plus 65, 185. So that means more than 180, you can't make a triangle. Sixth one, 53 plus 49 plus 78. What's the sum? 9 plus 8, 17. 17 plus 3, 20. 2 remaining. 9, 9 plus 4, 9 plus 4, 13. 13 plus 5, 18. So you get 180. That means you can make a triangle. We'll look at question number 4. The interior angles of a triangle are in the ratio 2 to 3 to 4. Find the magnitude of each of the angles. So here I can mark it as, if this is 2x, this one should be 3x and the other one should be 4x, because the ratio given as 2 to 3 to 4. So what's the rule? Sum of angles in a triangle adds up to 180. So I can write 3x plus 2x plus 4x is 180. So what's the sum? 3 plus 2, 5, 5 plus 4, 9x. So 9x equals 180. So what is x? I can divide both sides by 9. X equals 20 degrees. Now they want these angles. So what's the first one? 2x. So 2x means 2 times 20. So what's the angle? One angle is 40. The other angle is 3x. That means 3 times 20. So 60 degrees. The third angle is 4x. 4x becomes 4 times 20, that is 80 degrees. So here in this triangle, one is 40, the other one is 60, and the third one is 80 degrees. We'll look at question number 5. It says the magnitude of the largest angle of a triangle is 3 times the magnitude of the smallest angle, and the magnitude of the other angle is twice as large as the smallest angle. Find the magnitude of each of the angle. So here we need to mark this information in a triangle. So we'll mark it as ABC. So here the magnitude of the largest angle of a triangle is 3 times of the magnitude of the smallest. We'll take the smallest one as x. Then what's the largest one? 3 times bigger. So I can write 3x. And what about the other information given? The magnitude of the other angle is twice as large as the smallest angle. If the smallest angle is x, this becomes 2x. Now they are asking find the magnitude of each of these angles. So this is a triangle. The sum of angles in a triangle adds up to 180. 3x plus 2x, 5x, and 1x becomes 6x is equal to 180. So what is x? You divide by 6. You get 30 degrees for x value. But we want the other angles. Now one angle is 30. What's the other one? 2x. So x is the smallest angle. Now 2x becomes 2 times 30. That's 60 degrees. What's the other one? Largest angle. That's 3x. 3 times 30 is 90 degrees. So what are the angles? Smallest one is 30 degrees. The largest one is 90 degrees and the other angle is 60 degrees. Now we'll look at example number 1. It says prove that ABD, this angle, is equal to BCD, this angle, based on the information in the figure. Okay, so here what we can do, I can take the smaller triangle and write down ABD triangle and write down ABD angle plus 90 degree angle plus BAD angle (180). These three angles add up to 180. Then when I look at this triangle, what can I write? This triangle, if this is 90, this is also 90. That's a straight line. Now we can take 90 to the other side and write ABD angle plus BAD angle is equal to 180 minus 90. You get 90 degrees. And we'll take this as first one. And now look at the big triangle, ABC triangle. What can we write down? We can write down BAC angle, BAC or BAD angle plus 90 degree, this is 90 degrees, plus this angle ACB angle is 180, and when you take 90 to the other side, I can write ACB plus BAD angle is equal to 180 minus 90, 90 degrees. So that's the second one. These two equal to 90 degrees, so you can equate. So I can write comparing 1 and 2, I can write ABD plus BAD is equal to ACB plus BAD. Now, can you see BAD equal both sides? So here you can cross it out. So what happens here? ABD angle is equal to ACB, or ACB I can write as BCD. Same thing. So I can write ABD is equal to BCD angle. Now we'll look at example 2 in your textbook. In the quadrilateral PQRS, the sides PS and QR are parallel, already given. The bisectors of the interior angles P and Q meets at O. So that means bisectors means if this is X, this is also X. If this is Y, this is also Y. Prove that POQ is right angle. So here you have to show that this is 90 degrees. So POQ angle is 90 degrees. That's our question. So here when you look at the diagram, what can you say about these two angles? These two lines are parallel. Interior angles in between parallel lines is equal to 180 degrees. So here we can use that information to find out this plus this is equal to 180. So I can write SPQ angle plus PQR angle is 180. What you call that? Sum of interior angles inside parallel lines. Sometimes we call allied angles. Allied angles add up to 180. So here I want to divide the whole equation by 2. So SPQ divided by 2 plus PQR divided by 2, 180 divided by 2, I get 90 degrees. So here what is this angle? So divide by 2, I can write this inside angle. This is the inside angle. So I can write OPQ plus this angle I can write PQO. That's equal to 90. When you look at the small triangle OPQ, what can I say? This plus this angle adds up to 180. So I can write POQ plus OPQ angle plus PQO add up to 180. That's sum of interior angles in a triangle. And then we know OPQ plus PQO. This is 90 degrees. So I can write instead of this is 90 degrees. So what I'm getting? POQ plus 90 is 180. So POQ angle is 180 minus 90. So you get 90 degrees. So that's this angle. So they want right angle means show that it's equal to 90. So if you are using algebraic method without writing this, what we can write? Here straight away you can write, use the algebraic method. 2x plus 2y equals 180. Divide whole thing by 2. I can write x plus y equals 90 degrees. And then I can write if this is this POQ angle. POQ plus X plus Y is 180, but we know X plus Y is 90. You can write down 90 there. And write down POQ is equal to 90 degrees. If you are using algebraic method, you can show that one. Now we'll look at exercise 8.4 in your textbook, and it says in the given figure, ACP, this angle is equal to PBD. PBD is this angle. Prove that CAP angle, this one, is equal to PDB, this angle. That's what you need to show. Now we'll take this triangle and this triangle. What can you say? Here, if you take APC triangle, we know that ACP plus CAP plus CPA angle is 180. But we know this angle is equal to this. So, what's the rule? Here, vertically, opposite angles are equal. And when you take PBD triangle, I can write down DBP angle plus. So here I can write DBP, BPD plus PDB is also 180. So when I compare these two, I can see these two are 180. So I can write, comparing 1 and 2, I can equate. I can write ACP plus CAP plus CPA is equal to DBP plus BPD plus PDB. Now, I know these two angles are equal now. So that means this angle and this angle both are equal. So I can cross it out. And also, these two are equal. C angle and B angle equal. So this angle and B angle both are equal. It's given. So I can cross this out. So what I get now? I get CAP or ACP. What is CAP means? CAP. So this angle. Or I can write CAP. That's equal to PDB, this angle. So I can show that if these two are equal, these two also equal. Now look at question number 2. It says in the given figure, the diagonal AC of the quadrilateral ABCD bisects the angle BAD. That means if this is X, this is also X. And BCD angle also bisect. That means if this is Y, this is also Y. Now you are asked to show that ABC angle, this angle is equal to ADC angle. So that's what you need to show. Now we'll take the smaller triangle, ABC triangle. What can you say about ABC triangle? BAC plus ACB plus ABC. All three angles add up to 180. So what's this angle? So we can say if this is X, this is Y, this is X, and C angle, this is Y. So what can I say about X plus Y? I can write X plus Y is equal to 180 minus ABC. Now take the other triangle, ADC triangle. ADC triangle, what can I say? I can write DAC triangle plus ACD triangle plus CDA triangle add up to 180 again. Sum of angles in a triangle is equal to 180. So we know that this angle is X and this angle is Y. So how can I write this angle? CDA angle is equal to, or I can write other way round. I can write, what is CD? X plus Y angle. X plus Y angle is 180 minus CDA. Now when you look at this equation and this equation, both ones X plus Y. So I can write, by comparing 1 and 2, I can write 180 minus ABC is same as 180 minus CDA. So here both sides 180, I can cross it out. So what I'm getting, minus minus also, it get cancelled out. You get ABC angle is same as CDA. So here this is same as this ABC. I can write instead of CDA, ADC. So therefore ABC angle is same as ADC angle. Now we'll look at question number 3. In the given figure, AB and CD are parallel lines, already given there with an arrow. The bisectors of the angle BQR, this one. So that means X and X here. And QRD, this one. If this is Y, this is also Y. So similar to the previous question. Bisectors meet at O, find the value of OQR plus QRO. So here we'll try to do the first one. OQR, that means X. QRO, that means Y. So they are asking what's the X plus Y value. Okay, so here it says the parallel lines are now, we know these two angles add up to 180. So here first thing we can write BQR angle plus QRD angle is equal to 180. So that's 2x plus 2y equals 180. So I'm dividing all lengths by 2. So what I get? I get x plus y is equal to 90 degrees. So here can you see? They are asking what's the x plus y value. So I found that's equal to 90 degrees. Now the second part asks, prove that QOR is a right angle triangle. QOR. This angle is a right angle triangle. Now we'll take the small triangle OQR triangle. What's the sum of angles in a triangle? That's 180. So I can write OQR plus QRO plus ROQ. That's add up to 180. But we know two angles, that's R and Q angle. This and this add up to, this is R is Y, this is X. So X plus Y, this is 90. So 90 plus ROQ angle is 180. So what is ROQ angle? 180 minus 90. You get 90 degrees. So here they are asking QOR or ROQ. You can see that that's 90 degrees. So that's right angle triangle, means that angle is 90 degrees. Now we'll look at fourth question. Using the information in the figure, write down the magnitude of BAE in terms of A. BAE, this angle. Look at this triangle. So here what can you say? BAC plus 90 degrees plus A angle is equal to 180. So when you take 90 to the other side and A to the other side, what can you say about BAC? 180 minus 90, 90 and minus A. Because when you take A to the other side, it becomes minus A. So that's 90 minus A. Now second part, they want write down the magnitude of BDC. BDC plus DBC. DBC. This and this. Magnitude of this plus this in terms of A. So we'll take the A, not A, DBC triangle. DBC triangle. What can you say about DBC triangle? DBC plus BDC plus 2A equals 180. Sum of angles in a triangle is 180. So what is these two angles? These two angles add up to 180 minus 2A. I can take 2A to the other side. So here that's the second part. Now third part asks, show that BDC plus DBC is 2 times BAE. BAE means, or BAC is same as this angle. So this is BAE. So here when you take this one, what we found in part 2, I can see 2 is common. So I can take it out. When I take 2 out, I get 90 minus A. What is 90 minus A according to this one? That's BAE angle. So I can substitute instead of that BAE. So here they want these two angles is equal to 2 times BAE angle. Now we'll take question number 5. In the triangle ABC, it says A equals B equals C. So all 3 angles are equal. What's the triangle? Equilateral triangle. the bisectors of BAC meets the side CB at D. So when I draw the bisector, so this angle is, it meets BC at D. Find the magnitude of BAC. So here, first part, just asking what's magnitude of BAC angle. We know all three angles add up to 180. So I can write, if this is x, this whole thing is x, this is also x. So x plus x plus x is 180, 3x is 180, x equals 180 divided by 3. I get 60 degrees. So here, what's the magnitude of BAC? That's one angle, that's 60 degrees. And the second part they ask, prove that ABD is a right angle triangle. ABD is a right angle triangle. That means they are asking to show these two are equal. So how can we find out those two are equal? I can see that now if this whole thing is 60, what is this angle? This is 30, this is 30. And we know this is 60, x is 60. When I take ABD triangle, what can I write? ADB angle plus 60 degree angle plus 30 degree angle should be equal to 180 because this is a triangle. Those are the interior angles. So what is ADB? 60 plus 30, 90. When you take 90 to the other side, I get ADB is equal to 180 minus 90. That's 90 degrees. So here I found that this is equal to 90. So that means this is also 90. So ABD is a right angle triangle. So one angle is 90. So therefore ABD is a right angled triangle. Now we'll look at miscellaneous exercise, and it says in the first one, if A plus B is 110 and B plus C is 120 in the triangle ABC, find the magnitude of each angle of the triangle. So here in a triangle ABC, we know that A plus B plus C is equal to 180. It says A plus B is 110. So this part is 110 given. Then what's the C value? C angle is 180 minus 110. I can write 70 degrees. So C angle is 70. So here, according to the other information, A plus B plus C is 180. The sum of angles in a triangle is 180. But we know B plus C is 120. So here I can write A plus 120 is 180. So what is A? 180 minus 120, I get 60 degrees. So we found C is 70, A is 60. So what's the B angle? Again, I can use the first equation. 60 plus B plus 70 degrees is 180. So what's the B angle? So when you add these two, I get 130 plus B equals 180. So what's the B angle? 180 minus 130, I get 50 degrees. So we found B is 50, C is 70 and A is 60. Question number 2. It says the magnitude of BAC of a triangle ABC is 100. So we'll try to draw the triangle. In an ABC triangle, BAC is 100. So this is given 100. The bisectors of the interior angles ABC, I'll draw a bisector. If this is X, this is also X. And ACB, this bisector, I can put Y and Y. Meet at O. So this is O. Find the magnitude of BOC. BOC. So here what can we, so that's this angle. When you take ABC triangle, what can I write? 100 plus 2x plus 2y. This whole angle and this whole angle is 180. That's the sum of angles in a triangle. Now take 100 to the other side. 2x plus 2y equals 180 minus 100, you get 80. So what is x plus y? I can get x plus y by dividing whole equation by 2. So I get x plus y is equal to 40. We know x plus y is 40, so how can we find out the other angle? When you take BOC triangle, I can write x plus y plus BOC angle is 180, but we know x plus y is 40. So what is BOC angle? BOC angle is 180 minus 40. I get 140 degrees. So that's the BOC angle. Now we'll look at question number 3. In the figure, the straight line drawn from the point A perpendicular to the side BA, it's given, and ABC meets the bisector of ABC at P. So this is bisector, means this is 45, 45. Prove that BAC plus ACB is 2 times APB. So in this triangle, so here what can we say about this angle? BAC is A. ACB is Y. So here what can you write when you take ABC triangle? Y plus A plus 90 degrees is equal to 180. So what's this one? When you take 90 to the other side, I get Y plus A equals 180 minus 90 becomes 90. So here I found BAC. This is BAC angle. This one BAC, and Y means ACB is 90 degrees. Now here when you look at the question, it says this is perpendicular to the side BA. Can you see this is given as 90 degrees? So here when you take ABP triangle, what is APB angle? APB plus 45 plus 90 degrees is 180. So when you take these 3 angles, they add up to 180. So here what is APB angle? When you add these 2, you get 5, 13, 135. So you get 180 minus 135, that's 45 degrees. Now when you look at this angle, 90, how can I write? That's 2 times 45. So I can connect this and this here and write BAC angle plus ACB angle is 2 times 45. So 45 I can write as APB. So that's what is given there. Now we'll look at fourth question. It says ACB is 3 times ABC in a triangle ABC. So shall we write down, draw the diagram. In a triangle ABC, ACB is 3 times ABC. So if this is X, this is 3X, 3 times bigger. The bisector of BAC meets BC at E. So here bisector, if it's Y and Y, meets BC at E. The point D lies on AE produced such that AD and BD both are perpendicular. So here we can draw the line. So here when you extend the line, this is perpendicular and that's D. Prove that BC is the bisector of ABD. ABD, so BC is a bisector, means you have to show that this angle and this angle both are equal. So they are given ABC, take as X, BAC, take as 2A, BAC, take as 2A. So here they have given take as A. So I'll take this one is A, not Y. Okay, so we'll try to use A and X to show that this is also X. So here we can find out the relationship between X and A using the ABC triangle. So ABC triangle, we can write X plus 3X plus 2A is equal to 180. Then this is 4X plus 2A equals 180. So when you divide all sides by 2, what can you get? I get 2X plus A equals 90 degrees. So that's one relationship. Then what can I say about this one? I can take, when you take BDA triangle, this is 90. So here I can write 90 plus A plus ABD triangle is equal to 180. That's sum of angles in a triangle. So here what can I say about ABD triangle? 180 minus 90, you get 90, and then 90 minus A. Now when you take this one, this equation, what is 90 minus A? When I take A to the other side, I get 2X equals 90 minus A. Now what can you say about these two? I can write ABD triangle is same as 2X. So this angle I get 2X. So what is this angle? I get 2X minus X. I get X. So therefore I can write DBC angle is plus x is 2x. When I take x to this other side, I get DBC angle is 2x minus x becomes x. So, both angles are equal. That means I can say BC is the angle bisector of ABD angle. So that's what you need to prove. We'll take the last question. It says the line PQ has been drawn through the point A parallel to side BC of the triangle ABC. So there's an ABC triangle. The line PQ has been drawn through the point A parallel to side BC. So somewhere, so parallel line to this one. So somewhere there, P. And I can drop, this is P and this is Q. PQ line is somewhere there. And it says prove that the sum of the interior angles of a triangle ABC is 180. So how can I show that? I can take, when you take this one, this angle, I can write PAB angle, that's equal to this angle. That's ABC. What's the reason? Alternate angles. Then I can write this angle is equal to this angle. Again, alternate angles. QAC is same as ACB angle. Then I can add this angle to both the equations. I can write BAC. Then I'm adding all three together. So I'm adding PAB plus QAC plus BAC is equal to ABC plus ACB plus BAC. So what's this side? These three angles are the angles inside a triangle. Now what is this side? This plus this plus this. What's that? We know that's a straight angle. So I can write this is equal to 180 because of straight angle. So what can I say? The angle sum of a triangle is equal to 180 degrees. In this lesson, we covered two theorems. One is exterior angle is equal to sum of opposite interior angles. And the next one is we learnt about sum of angles in a triangle add up to 180. So when you get triangles, use those two theorems in applications.